Hello, Chapter 2, Lesson 1. Oh, that's ridiculous. Chapter 1, Lesson 2, Advanced Algebra. We're going to look at algebraic expressions, and this really is a review, so I'm going to move very quickly through here, but there is one comparison of two terms I really want you to pay attention to and learn the vocabulary so that when we're talking about it in class, you know what I'm saying. So look for that as we're going through this lesson. Okay, algebraic expressions, we want to look at evaluating and simplifying. And this is what I want you to know. We're going to tell you what they are in a minute. But I really need you to know what's the difference between evaluating and simplifying an algebraic expression. What's the difference between the two? It's really important that you know the difference between those two things. What does it mean to evaluate an algebraic expression? And what does it mean to simplify an algebraic expression? So we want to look at those two things together. And again, make sure you know the difference between those two things, because I will ask you to write them down. Okay? All right, evaluating, let's look at that. Evaluating first means you substitute numbers in for variables and then follow the order of operations in order to simplify it. So evaluate means you're going to substitute in and then do the arithmetic or do your order of operations to come up with a final answer. So evaluate means to substitute and simplify. If you wanted to break it down to a very simple couple of words, evaluate means you substitute into the expression and then you simplify. That's what it comes down to. Substitute and simplify. That's what evaluating is. Substitute and simplify. Okay? Well, that may mean you don't know what a variable is, but I'm sure you do. A variable is a symbol. It's usually a letter, most times X, but in advanced algebra we're going to use a lot of different letters, so it can be any letter. And that one letter represents usually one number, but you're going to find out later that it can actually represent more than one number. In other words, there may be two different numbers that you could put in for X and still make the expression true. So keep that in mind. So a variable is a letter. And then what's an algebraic expression, seeing how we are evaluating algebraic expressions, an algebraic expression is simply an expression that has one or more variables in it. Okay? And that's called a variable expression. So these are the key terms that you're going to need to know. So what does it mean to evaluate? Substitute, simplify. Okay, so let's do one example for us real quickly. What does it mean? So the instructions are to evaluate each expression. So here I'm given the algebraic expression here, 4 times the quantity 2m minus n minus 3 times the quantity 2m minus n. And it tells me that for m, they want me to put in negative 15, and n, negative 18. So to evaluate, that means to substitute and then simplify. So let's go ahead and substitute in first. Now I'm going to show you something here that I want you to do, and that is every time you have a letter, I want you to go through and rewrite the expression, and for every letter, put in a parentheses before you put in the number. And this will save you from losing a negative sign along the way. So let me show you what I mean. So 4, and I already have a parentheses, 2. Now for this letter, I'm going to write a parentheses, not put anything in it. That's my m minus n, and then so I rewrite this, and for every letter I write a parentheses. Then I go back and put the number in. So for this m, I put in negative 15. And then for this n, you put in negative 18. And the reason I want you to do that is because right in here, what's going to happen is you're going to put in negative, and then you're going to see, oh, it's negative 18. You're going to think that's already there, and you're going to make a mistake. So in order to protect yourself from making that mistake, write a parentheses for each letter, okay, first, and then go back and put the number in. So it's 3, then minus 2 times m minus n, and then go back. M is negative 15, and n is negative 18. So then we follow order of operations, and then we simplify it. Okay, order of operations means we do parentheses in first. So I have 4. The 2 times negative 15 is negative 30. Minus a minus is plus 18. And then I have minus 3. And then I have 2 times negative 15 again, minus 30. And then again I have minus minus, so that's plus 18. So now I can go ahead and add these inside here. So 4, negative 30, and 18 is negative 12. And then minus 3 times, and add those, negative 12. Now I can distribute. 4 times negative 12 is negative 48. Negative 3 times negative 12 is a positive 36. And then I can add those together, so I end up with negative 12. So to evaluate, I substitute, and then I simplify. But remember, when you're substituting, use parentheses. That'll save you from making a lot of mistakes just by doing that. It's a careful thing you need to do. So we get a negative 12 is our answer for that. Okay, so that's the first topic of this lesson. The next thing we want to look at is now simplifying algebraic expressions. So remember, an algebraic expression is an expression that has variables in it. Now here we're talking about simplifying. How is simplifying different than evaluating? Keep that in mind because I want you to know the difference. So evaluating is substituting and then simplifying. Simplifying an algebraic expression means, well, there's a couple vocabulary words we want to look at. What's a term? A term can be a number, a variable, or a product of number and one or more variables. So if you're looking at this algebraic expression down here, a term, each one of these is its own term. You have a positive 5x, you have a positive 7xy, and you have a negative 37zx. The sign that's in front of the number goes with that term. So you have 3 different terms. 5x, and that's a product of a number and a variable. 7xy, that's the product of a number and 2 variables. And then negative 37zx, that's a product of a number, negative 37, and then z and x. So a term can be a number by itself, a variable by itself, or a product, like I have here, of number and then one or more variables. Now, another word is coefficient, and we're going to use this a lot this year, so make sure you really get this definition down. The coefficient is the numerical factor of a term. Basically, it's the number that's in front of all the variables. So here I have the term 5x. The coefficient of that term is 5. That's the number that's in front. The second term is 7xy. The number that's in front of that is 7. That's the coefficient. And the last one here, we have the term negative 37zx. What's the coefficient of that term? It's the negative 37 that's in front. So the coefficient is the number, and this is all multiplication. It's negative 37 times z times x. So the number that's in front is called the coefficient. Okay, so that's the vocabulary of this. So now what does it mean to simplify? Simplifying means you just add the like term. So simplify means you add any like terms. Well, that means we have to remember what are like terms. Like terms are any terms where you have the exact same variables raised to the exact same powers. Everything has to be the same. All of the variables have to be exactly the same, and the powers have to be exactly the same. If that's the case, they're called like terms. And if they're like, I can add them. And to add them, we simply add those coefficients that are in front. So let me go back to the previous page really quickly and take a look at these. So here we have these terms. Are any of these like terms? Well, if I look at this term, it has an x to the first power. Here it has an x and a y. Are those the same, exactly the same number of variables? No, this one has an x, this has an x and a y. Here's a z and an x. Is that the same as any of these? No, they're all different. So none of these are like terms. So actually you couldn't simplify this any further because you can't add any of these together. You can only add like terms. So simplifying means adding like terms. Now how is that different from evaluating? What's evaluating? Substitute and simplify. Okay, what is simplifying? Adding like terms. That's the difference, and that's what you need to know. So for this lesson then, one problem you might have to do, well, let's look in your textbook. Let me get back here, and let's go ahead and do one example. I'll do one example out of your book, okay? And so we have 2a, let's say we have 2a plus 3b plus 4a, and I ask you to simplify. Okay, what does simplify mean? It means add like terms. So I'm looking for variables that are exactly the same. So here's an A and they're B. Not the same. Here's an A and an A. Those are exactly the same. And so I can go ahead and add the coefficients. So this is 2 and this is 4. So I can add the 2 and the 4, so that's 6A. And then I can't do anything with the B. There's nothing I can add it to, so that stays the same. So this would be my answer. Now notice, I didn't change the A. The A is just the A, and there's nothing you can do with it. You don't do anything to it. All right, you leave the variables alone. The only thing you do with the variables is you use those to identify whether you have like terms or not. Once you've established the fact that you have like terms, then you can go ahead and add the coefficients. Okay, let me do one more problem for you out of this lesson here. Let's do this one here. 3y minus 4y plus 6x. Okay, so whenever I have parentheses, I need to remove the parentheses, and I can remove the parentheses by distributing. So I have 3y, and you multiply the negative sign times each of these. So it's negative 4y, and then minus 6x. Now I'm looking for like terms. Here's a y, and here's a y exactly the same, so I can add these. So 3y minus 4y is negative 1y minus 6x. Now while this is correct, there's a matter of convention here, and you'll hear me talk about this a lot this year. In other words, what I'm saying is, while this is correct, we have conventions in math where we want everybody to do the same thing. So even though both answers could be the same and really have no numerical difference, there is a way that we want to present our answers so that everybody's presenting it the same way. And one of these conventions that we do is we never leave a 1 in front of a variable. We don't leave it like that. We want to take it one step further, and we can say, well, what's the multiplicative identity? What is negative 1 times y? It just ends up being negative y minus 6x. So this would be the answer that I would want, because this is a matter of convention. We don't leave the 1 there. So I don't want you to leave 1's in front. I want you to remove those and make the answer look like a mathematical answer should look. As a matter of convention, we all do it the same way. And nobody leaves a 1 in front as a final answer. So make sure you don't leave a 1 in there as a final answer. There's no difference between the two. They're exactly the same, but as a matter of convention, we don't leave the 1 in front. Okay? All right. So go ahead and tackle your homework, and we'll see you in class.